A solid body starts rotating about a stationary axis with an angular acceleration beta is equal to at, where a is a constant. How soon after the beginning of rotation will the total acceleration vector of an arbitrary point of the body form an angle alpha that is equal to 60 degree with its velocity vector? Now, in order to understand this situation, let us first sketch the problem. Let this is a solid body, and it is rotating about this stationary axis. Clear? Say it is rotating like this, say with angular velocity omega. Now if I consider this point P, and if you observe carefully that when this body rotates, this point will move in this circle. Clear? So I am drawing the circle here. This point P will describe a circle. Clear? Now what we have to find out, that if this body is accelerating with an angular acceleration beta that is given by this result, I have to find out that after how soon, means I have to find the time. I have to find the time after the beginning of rotation that the total acceleration vector of an arbitrary point, that is the point of the body, form an angle alpha 60 degree with the velocity vector. So we know that the velocity vector is tangential to the circle. Clear? So this is the velocity vector. Now as the body has an angular acceleration, so this point P has two accelerations. One acceleration is the centripetal acceleration towards the center of the circle. Here it is the axis of rotation that is passing through the center, and another acceleration is the tangential acceleration, and the resultant of this tangential and the centripetal acceleration is the total acceleration, and that will act in this direction. So this is the total acceleration, and what is given, this alpha is given, this angle alpha is 60 degree. So he is asking that at what time this situation will happen. From this information we can write tangent of 60 degree in this triangle. If you see carefully this triangle, this tangent of 60 degree is equal to AC, the centripetal acceleration, divided by the tangential acceleration. Clear? And tangent 60 degrees under root 3, it is equal to AC by AT. Now in order to calculate AC and AT, we need V. Clear? Now in order to calculate V, we can use this result. So this is angular acceleration beta, and angular acceleration is d omega by dt, that is equal to AT. Now from here we can find out omega by integrating this equation on both sides, and from here you can write omega is equal to half AT square. Clear? Now suppose the radius of the circle is r, so the velocity, the magnitude of the velocity, you can write V is equal to r omega. Omega we have calculated, so we will get half ART square. Now AT is equal to dV by dt, rate of change of speed with respect to time, and if you differentiate this V, we will get ART. Clear? And this centripetal acceleration is V square by R, and if we substitute the value of v, if we substitute this result, we will get AC as 1 by 4 a square t raised to the power 4 into r. Now if I substitute this AT and AC here in this result, so I will get under root 3 is equal to AC. AC is 1 by 4 a square t raised to the power 4 r divided by AT. AT is ART. So R gets cancelled, A gets cancelled, and only A is left here. So from here you can write T cube is equal to 4 under root 3 divided by A, and solving this we will get T is equal to 7 seconds.